Okay, hello everyone. So before we start, I would like to ask how many of you knows React already? Okay, quite a amount. And how many of you got an idea what Fiber is? Okay, good. So today we will try to highlight differences between the current implementation of React and the React Fiber, and answer the question if Fiber is ready yet. But before we do, let us introduce ourselves. My name is Michał Chudziak. My GitHub name is Mike866. I work as a full-stack developer in ColdStack.io, focusing mostly on React, React Native, and Node.js.
Yeah, hi, my name is Wojtek Szafraniec. I'm also a full-stack developer in ColdStack, and I started working with React, but then I jumped into React Native for whole last year. But yeah, it's the most important information about me for now, I guess. Yeah,
okay.
We'll go.
Great. So maybe at the beginning, let's say a few words about the React architecture. So the way React is designed is to separate the reconciler and the renderer. They are two different things, and the fact that they are separate actually make React really flexible and extensible for other platforms. We'll get to it later in the presentation. But you might wonder what reconciler is. So if you are familiar with the thing which is called virtual DOM, this is what's reconciler. While DOM here is not the very best term, because reconciler from React can be attached to any other platform like React Native hardware and stuff like this. It's just a separate part. The renderer is something which takes care of actually making translating our concept into real life structures and datas. So what is Fiber? Fiber is ongoing implementation of React. The goal of Fiber is to increase the performance in key areas of application like animation, gestures, and things like that. It's done by splitting the work into some very small chunks and spread it out over the multiple frames. In some basic words, we can say that Fiber is smarter than React was. It gives the React some management skills, let's say it, and manages the work for us.
Yeah. Okay. So we split our presentation into two main parts. First part will be about the reconcilers, about the current architecture of the React, and about the outgoing feature of the React, which is Fiber. And yeah, let's start with the most important question. What the reconciler really is. So yeah, reconciler is an algorithm which React uses to find the differences between one tree and another tree, and how to do it in an efficient way. And we cannot misunderstand the reconciliation with the update, because update is something like changing the data in our application. It's usually set state, which ends up with render another tree or re-render. The most important part about this algorithm is that to think about each renders, like re-render whole application from the scratch, for example. But it helps developer to think more declaratively how to achieve something, instead of thinking about the transition between the screens and so on. We do not need to care what happens if we change state from point A to B, from B to C, and so on. We just declare what we want to do, and React does everything for us. And about the rendering the whole application from the scratch, it maybe would work with the really small application, but when we went to world of big application, the performance would be really bad. But React implemented algorithm with complexity of n, where n is number of elements in our tree of elements. And yeah, I would like to say a few words about current stack reconciler, how it works. Earlier it was just the stack, it was just reconciler, but when Fiber jumped in, it changed the name to the stack reconciler. But how it works? It's pretty simple. We have render method, which returns the tree of elements with current state of the application. So if any data changes in our application, render will return the new tree of elements. And React need to figure it out how these small parts changed from the first tree to another tree. And let's go to the simple example. Probably every one of you who was working with React knows this example. At the left, we can see the tree with red elements which are marked as a dirty. So their state has changed and need to be updated to get the proper UI. And how reconciler works? It goes from the top, from the root element, and finds out which element has changed and need to be updated. And if React finds out the dirty element, it wipes out the whole tree below the dirty element and re-render it again. Maybe we will try to go deeper about the core algorithm, and it's based on two main assumptions. First assumption is that the two elements of the different types will produce the different trees. So for example, if we have div tag and p tag or emg tag, the trees will be different. So React will figure it out. I will try to explain I will try to explain it in next slides. And the second assumption is that we, as a developers, can mark any child element with the key prop, which will help us. This key need to be unique, or it should be unique, because it might produce the bad performance, but it will help us to make reconciliation faster in some edge cases. So yeah, how diffing algorithm works itself. Firstly, it has different behavior if we have different types of elements on the top. Firstly, if elements has the different type on the top, like in this example, we have view tag on the top, and then in next render, our application would like to have the touchable opacity on the top, so something which is related for pressing items in React Native. And what reconciler does, if it finds out the element is different, it will wipe out our tree and create another one from the scratch. So it will destroy all nodes in our application, will invoke React lifecycle methods like component will unmount, and to the new DOM nodes which are inserted to our DOM, will invoke another lifecycle methods like component will mount or component did mount. Probably no one of us is using component will mount, but whatever. And the state associated with our old tree with view and old text with example will be lost and inserted the new state. And yeah, what happens if we have the elements of the same types? Like in this example, we have two text components, text instances, and React finds out that style has changed. And we do not destroy the old nodes. React just iterates through the attributes of our component and finds out which are different than before and apply these changes and invokes the other lifecycle methods of React, like component will receive props and component will update. Another example of diffing algorithm is about the recursing on the children, and our example is simple list. We have an unordered list with two items, first and the second, and to this list we want to add third element at the end. So React goes through the children's and matches the first two items, and it's okay. Second item's also okay, and adds third item at the end. But what happens if we have two elements with Ferran and Raul, and we want to add Anna on the top of these elements. React do not find this subtree because matches iterating the children's and matches the elements. And Ferran doesn't equals Anna, so we'll mutate the whole children's, which means the bad performance. But React comes with solution with keys. So if we add the keys to our elements and want to add Anna with key 1, React will find out the subtree easily and add Anna on the top with still great performance without unmounting components, for example.
Okay, so now that you know how old stack-based reconciler works, you probably wonder what's different in Fiber. So the first main thing is the scheduling, ability to determine when the work should be performed. And while thing we call work is anything that, any computation that actually is performed within your app, in example, the result of the set state or something like this. In Fiber, it has a more specific name, unit of work. And those units of work, thanks to scheduling, can be prioritized, can be deferred, reused, and canceled. And thanks to that, we can start working on something, on some heavy computation, stop it, perform the animation, and go back to the previous computation. And have no lag for user, yeah? So user experience gets better and better with that. Yeah, React handles it under the hood, so it's very smart. But let's remember that scheduling is very important, and let's go to some real-life example. So assuming that I have some short to-do list for today, I have to get drunk and visit my girlfriend's parents. So without scheduling, with stack-based approach, I will take the thing from the top, which is getting drunk. And while it might seem like a good idea for most of you, it can eventually lead to the fight with your girlfriend and you can end up alone, right? So scheduling is important. We have to remember that because the way we organize our work, it can result in way better performance. Second one is the incremental rendering. So we probably are familiar with this kind of code. It's just regular component which returns another element, let's say. And this has this kind of boundaries between each other. So we have parent and we have child. And they have the pointers to each other. And this way we cannot return the multiple child from the React component because of these boundaries. And Fiber introduced a thing called siblings. And actually it results in possibility of incremental rendering. So now we have our parent component, and it points to the first child. It has a pointer to the second child, also maybe to the third, and also those has the pointers to our parent. Yeah, so with Fiber, I don't know if incremental rendering itself was intended, but it turned out to be really powerful features. In everyday development, you would love to use this returning arrays thing. Yeah, so summing up, the main benefits of Fiber at this moment is scheduling work. In example, Fiber schedules animation over data update. You will see in examples how it looks in real life, and the incremental rendering. Of course, these are the benefits of the reconciler itself, because also renderer got a bit changed, but we'll get to it. So let's see the examples.
Yeah, so how about the examples? We know at the moment some basics about the stack reconciler and fiber reconciler, but we can check how it works in real life. So this is example of Sierpiński triangle. It's probably one of the most famous examples of the fiber pluses. And we can see the one main triangle, and on each edge there is another triangle which contains the node inside of it. And as we can see, the animation isn't smooth, but on each transition we can see that data inside is updated in good moment, because all of the work is done linear, like all of the work needs to be done. In fiber, as you can see, the animation is really smooth, but the data inside of our nodes doesn't change in each second, because fiber do not have time to update the data inside, because animations has higher priority, and fiber checks how much time it has to the next frame. It's about the 16 milliseconds to keep animation smooth. So if he didn't update the whole data inside our structure, it aborts it and puts only the animation changes to our application. And the next thing is about the rendering and how it works. So, as Mike said before, rendering and reconciler are two separate phases. Reconciler is about finding out how the structure has changed. Renderer is about seeing the output on our screens, on UI, and so on. The separation means that the DOM, React Native, and other renderers can be used with reconciler. But with fiber reimplementation, the renderers needs to change a bit also. But let's go to some terminology about components, elements, and instances, how it looks in current stack reconciler, current architecture in React. So yeah, probably most of you know that. It's the definition of the component, which uses React API. It returns p tag and the children. Element is something when you use JSX to your component, like here, or you call for the React API to React create element. What is element? Element is just the plain object which contains the which describes component instance and its properties. What's instance? For example, we have state, props in our component. Instance is this, what this refers to, so to our instance of the component, the current state of the component.
Yeah. Yeah, so in Fiber it's a bit different. So going to the previous slide, instance was referring to this keyword. And as you can see, instance in Fiber is a bit different. It's just the call over what's returned from create element of React DOM Fiber component. And why is it changed? Because of little data structure called Fiber. And this data structure actually contains the information about the priority of our instance. It has the pointer to the instance, it has the type key, and all the descriptions we need. So actually, now it's time to go to the renderer. We don't have many time, so we will just go roughly through it. Renderer itself turns elements description into the target instances. And how renderer looks like, sorry, yeah, here. It's, in real life, it's way more complex API, but here, to make renderer work, we just need to implement the render method. The second one, unmount component at node, is not mandatory, but it's really important to have it. But render method itself takes your JSX element as the first argument, or the call over the React create element, the container as a second, which is also the React element, and the callback to be called after rendering is finished. But we have to remember this, unmount component at node is important method to clean up after yourself. There is way more in rendering itself. Thing called custom renderers is the next big change of React Fiber. Now it's not that exposed. You can create custom renderers because React itself, when I started working on it like 3 years ago, it was just the DOM version. So it was just a framework to develop the web applications. And year after, it was ported to the iOS, so React Native came in. We were able to map our JSX into native iOS modules like UI View, UI Navigation Controller, things like that, straight to Objective-C. Thanks to the changing of renderer, they just took off the renderer which rendered everything to the DOM and push it into the iOS environment. Then half year or a year after, I don't remember now, Android version came out. So React Native went cross-platform. It went also mapped to the native Android components, Android.view, things like that. And probably React Native is still somewhere there because Android has some issues. It still can be improved, but you have to remember React Native is production ready at the moment. We are developing it over a year. So if somebody is telling you that, nah, it's buggy, fuck it, no, it's ready. So don't worry. And there is many more to come because of the structure, how it's designed, and actually thanks to the first class custom renderer API, which comes in React. I don't know if 16.0.0, but in some near future for sure.
Okay, so probably these are the most important changes in the Fiber which Mike mentioned, but the core idea of React 16 was that to replace current stack reconciler with Fiber reconciler and get it stable and smarter and support the older version of the stack reconciler. And what's important, learn once, write everywhere. So all of the application will share the same reconciler, but we can create custom renderers. Few of them are already done, like React Hardware, React Native Windows for Windows Phone, React Blast for the console, and also new features in React 16+. So after releasing React 16, which should be in few days or weeks, there will be new features like Exposed API to make whole application smarter as we want, to put priorities on the elements, to create the app how we want, to make it smooth and get great user performance experience.
Yeah, so the main question today, right, is Fiber ready yet? Do you want to answer?
We can check. We have iframe.
Yeah. No, it's not. But there are only 4 tests left to fix, and it's development only. So we can expect Fiber, at least version 16.0.0, to be out real soon. It doesn't have all the Fiber planned features, but it will be extended over the time, for sure.
For example, React Native still do not support the siblings, which web does.
Mm-hmm. And yeah. So those small things, you have to keep it in the mind. Yeah. And if you want to learn more about Fiber itself, because there are not many sources over the web, you can read some articles, there are not many of them, some GitHub notes, but what we found as most important was the presentation. First one is the presentation of Lynn Clark from the React Conf 2K17 a cartoon into React Fiber. So it gives you general good overview over the Fiber architecture and how the reconciler itself works. So feel free to find it on the YouTube. Second one is a tiny React renderer from Dustin Kasten. We didn't have enough time to introduce you into the topic of custom renderers, but here you can gain a bit more knowledge how to develop a custom renderer. He shows actually an example of React hardware. So he has Arduino in here and just doing the React renderer to Arduino. And the third one is Fun with Custom Renderers from Ken Wheeler from React Amsterdam this year. And yeah, he shows you how to render some sound effects with React. So that's actually another great one. And yeah, feel free to Google. Fiber is not ready at the moment, but it will be soon. And we believe that it's a big change. Maybe at the moment, not really something you would feel as from the developer perspective, but from the user perspective, I believe user experience would be increased. Yeah, thank you. So do we have any questions? Before we start, I just want to say that if you are interested in joining Coast.io, we are a React-specific software house based in Wrocław. Feel free to send your application here. So questions, please.
Wait a minute. Hello. So 3 years ago, when React was heavily promoted, they said like they are super fast because of Virtual DOM. But actually they were really slow comparing to existing frameworks. So my question is, do you have benchmarks for this super fast Fiber?
I don't know if I'm the right person to answer this one, but I believe React, back in the days, Virtual DOM was the great concept, and it's bring an improvement into the world of web app development. And with Fiber, it's not that React, it's getting way different. It's just getting smarter, and you are just scheduling the work in different ways. And I don't know, in example, if any other frameworks follows this pattern at the moment. I'm not into Angular very much since I started React, but yeah. That's all I can say about it, actually. Maybe you want to add something?
Did I understand this correctly? So you have the presentation about the music on the last slide.
Yeah.
So you have the separate renderer, and so you can basically put music into HTML and then render it?
You don't even have to put it into HTML. You can map it to whatever you want. React Native maps it into native UI components of iOS or Android.
Yeah, but it's HTML, right? So it's like a tree structure. It's like HTML, like kind of a.
Like I said,
syntax.
you can map it to whatever you want. So if it's any kind of HTML, right? Or what you said? Because
just like HTML, like a tree-like structure with the
any tree-like structure, you can implement the custom render for this.
Oh, okay.
Yeah, even if it's something like Unity, it's like very popular game development framework.
Okay.
I believe it uses trees as well. And actually, we made some attempts to port React here. It turned out not that easy back in the days, but maybe now with custom renderers it will be better. But any tree-like structure, you can put custom renderer into it.
Okay, thanks.
Thanks for presentation. And what is used under the hood for this Fiber? I mean, request animation frame, web workers, request idle callback. What is
It bases
under the hood.
It bases mostly over the two things you mentioned. So it's request animation frame and request idle callback, and it uses it to schedule the work. I know that in React Native example, the two of those methods are implemented to work natively, so it's good. In DOM as well, in web, in browser, but in other environments, I'm not sure, but under the hood, it uses those two.
But is it solves the problem? Because the bottleneck not is virtual DOM and definite. The bottleneck is changing the DOM. It's the slowest stuff.
Yeah, but like the goal of Fiber is to, you know, improve the overall performance. So it's, if something's slow, it's getting its time, it reaches the deadline, work is getting paused, then the other work comes. So in example, if we have the let's set state, which takes 10 seconds. I know it doesn't take that much ever. And animation, which takes 1, but it's multiple of them. It will just maybe go the first 5 seconds of this set state, proceed with animation, then finish the set state. So, you know, it's all about scheduling in Fiber.
Do they have plans to work with WebAssembly, for example, because it could be used for such stuff, because you can separate on different threads, you can use shared arrays, buffers, and so on.
Yeah, I know that React itself works on the main thread, just one of them, but it uses the Fiber uses the two trees. First is the current rendered tree, and second is the work in progress tree. So in work in progress tree, there is some work which is being done. Maybe let me show this to you. So we have our host config here. It's being cloned at the beginning. This one to this one, yeah. So we have some elements. And the big advantage of Fiber is that if it stopped our, oh, sorry, they are not the same. Oh. If it stopped our work here and some component is being updated here, and our deadline is being reached, pointer from the work in progress tree goes right to the current tree and leaves the state unupdated. There is the better explanation over the first link with Lynn Clark presentation, and she tells exactly about this. So I recommend you to watch it. But yeah, that's another big thing. But we didn't really have time to go that deep into Fiber itself.
Okay, thanks.
Any other questions? Okay. So if I understood correctly, Fiber claims to be faster in general usage. Where does this speed up come from? Do they understand correctly that it's just aborting some work to carry on with other, or what are the main speed ups?
Do you want to take this one? Okay, so generally faster is not a good word. It's more performant. It brings better user experience. And that's why we might think it's faster. If you could see if you noticed on the example, the numbers inside the circles weren't always updated. So we lose something, but we gain other things, you know? So the priority to animations, we can feel like our app is fast, but our user don't care that much if the result from, I don't know, API call or from any other data mutation is delayed by those 200 milliseconds. So yeah, one thing is being delayed, other things jumped in, but goal is to make user feel it faster, not being exactly faster.
Okay, so thank you. And now we have